All right. I have a sneaking suspicion that I'm not going to feel like doing a whole lot on Monday, and it's going to take me some time to acclimate and get back to um, I guess, just life outside of this bedroom. Um, so what I thought I would do is make the notes on 2.5 and 2.6, combine them together as briefly as I can, and then that way you have something to look at before Monday where you're basically going to more or less teach yourself because realistically I'm going to be trying to like put my classroom back together in case you guys destroyed it while we had a substitute, or I get set for, I guess, the next chapter. I have some Barbies to conduct surgery on, so we'll see how that goes. um, in any case, I figured we'd run through 2.5 and 2.6 now, to give us a kind of a head start going into next week. So these are the 2.5 notes. Will Marty make it back to the future? I've gone ahead and taken the number one and gone and labeled all the pieces of the normal distribution. So that's because questions 2, 3, and 4 ask us to approximate, um, or calculate the percentage of um, speeds between or greater than or less than a particular value. So now remember, for all of these, if you really wanted to, you could just plug these into the calculator. I'm going to show you how to do that in the 2.6 lesson, but for now, all we have memorized is the different percentages for each slice, right? So the DeLorean speed greater than 87.7 miles per hour. Let's use hot pink. 87.7 miles per hour is right here. Greater than means that they're interested in this area under the curve. So you just add up those sections. So it is 13.5 plus 2.35 plus 0.15. And if you do that right, you should get about 16%. So this is a 16% of runs are a speed greater than 87.7 miles an hour. The same thing applies for number 3. Um, what percent of the runs will give a speed between this and this? So we kind of already went through these. I'll change colors. Let's use some little bit of doo-doo brown action. 64.6, so from right here, to 87.7, so here. So we're talking about this area here. So this giant area here, this is 34 and 34, which is 68, and then plus 13.5, so I think that's 81.5. 34 plus 34 plus 13.5 should equal 81.5. 82.5? 81.5. What percentage of the runs will give DeLorean a speed less than 68.45 miles an hour? Let's change to a little bit of Tiffany blue. Less than 68.45. Now, here's where we run into a problem. When you have a number, like in this case, that's not a perfect one hole or two hole, three standard deviations above or below, there's no way to memorize that. You'd be memorizing quite a lot of numbers if you tried. So you just kind of have to ballpark where 68.45 is. Obviously, it's somewhere between 64 and 72. So it's like, I don't know, 68 is a little bit closer to 72. So maybe it's like right here. Okay, so this, we're going to treat that as 68.45. So this, and we want speeds less than that. So really we're interested in this robin's egg blue area here. So we want to know what that area is. Well, um, good news. You have a way to find that. Um, we have the formula that we can fall back on, which if you wanted to, you can calculate the formula for any of these, and this method I'm about to show you will work, but we're going to take the speed, this 68.45, and we're going to create a standardized score for it, where the mean is 80, and then the standard deviation was 7.7. So your calculator will do this. Okay, so do this piece in your calculator. All this right here. Do this in your calculator. When you do it in your calculator, let's see, what do we come up with? This should be negative 1.5. Okay, after you simplify. So your calculator will spit out negative 1.5 for this, but the hell does this number mean? This means nothing to me. Well, remember what this represents. Now that we've used the formula to solve for this, this represents the number of standard deviations away from the mean. And because it's negative, I know that it is to the left of the mean, so it's less than the mean, which checks out with the picture that we just drew, right? So we take that number, that's to the left of the mean, it's less than the mean. And it is, in fact, between 1 and 2 standard deviations below, so 1.5 is about right. But that is not a percentage. So what percent of the runs will give the DeLorean a speed of blah, blah, blah? That requires something like this. And this is just, I mean, this thing is gross. There's just no other way to put it. This is actually taken as a screenshot straight out of the AP Statistics 2022 FRQs. So this was this year. This was provided to the students taking the test in May. All of these numbers inside the table, this is just hundreds of calculations at particular z-scores. So in our case, we have a z-score of negative 1.5. Well, that means we're on this version. See here how all the z's are negative? On the other side, we have all the z's are positive. So I want to be on the first page, and I'm going to go down the left column until I find negative 1.5, which is right there. And then you will travel across the top. So you're going to go down this column first. Now you're going to travel across the top row until you find the next digit. Well, there wasn't a next digit when we calculated negative 1.5, so we're just going to use this one, showing us that our hundredths place is actually 0. And then you scroll down, and then we look at whatever value corresponds to both of those. So this is 0.0668. Now, I'm not making this up. It's right here, 0.0668. So that's how you find such a thing. This is called Table A, which it kind of doesn't matter because realistically, this is AP stuff. I've printed these out for you. I should have them at some point this week, but this is a table that's going to be very helpful for you. So this is basically how we get these answers. This table is some calculator that has computed the areas to the left of all of these z-scores. So every z-score possible on this chart has been calculated and rounded off, and then there it is. So all these 4-digit decimals inside the table, all of these are areas. And on the outside of the table, you have your z. So your z is down this and then across the top. So that's how you kind of find your z-score. You can also read the table backwards. If I give you the area or a percentile, you can read into the table. Say I say the 90th percentile. Well, I can scroll down, and I know I need to be to the right of the mean because that's where the 90th percentile would be. And I look within the table to find whatever decimal is going to get me closest to 0.9 because that would be the 90th percentile. I think this number right here is our winner. 0.8997 is closer to 0.9 than 0.9015. So this right here, winner, winner, chicken dinner. We need to find the z-score associated with that. So we read from the side, so positive 1.2, and then we read the top, 0.08. So the 90th percentile would be 1.28. That is your z-score to reach that place. So you can read the table forwards and backwards. And it's very helpful. All right. So I'm just going to show you these. We're going to kind of go fast. We're already at like 9.5 minutes here. So here we go. Okay. Just as a note, that table that I just showed you is areas to the left. It says so on the table. It says so up here. The probability lying below z, so it's the area to the left. But it's kind of easy to forget that. So it's the area to the left. Next, you'll notice that anytime I do one of these questions in class, I'm going to be drawing some kind of really crude, kind of crappy normal curve. And this is so I shade the right direction. Because if I'm given something like this, I think this is the exact example that we just did on number 4 or 5 on the previous page. You're shading to the left. So the direction you shade will tell you what you're looking up in the table. So you look it up in the table, and then you know you don't have to do anything with that number. You just take that number and go and you stick it right there. So now that you've stuck this number here, you're basically done. So calculate your standardized score to get your z-score. Use the table to convert your z-score to an area, or your z-score to a percentage. Technically, it's also a probability. What percentage of the runs will DeLorean give a speeder greater than 85 miles per hour? Same thing. It's the value that you're interested in minus the mean divided by the standard deviation of that thing. That produces a new z-score. And because of the language, because of the wording in the question, this is a speed greater than. So I'm shading to the right of that location. So at 85, I shade to the right. And then I'm going to use the table to figure out the area to the left. But I believe we've talked about this. The area to the left and the area to the right must add up to 100%. That's a rule because the standard normal curve is what is referred to as a density curve. The area underneath a density curve always totals to 1. So if I know the area to the left, I can do 1 minus that to find the area to the right, which is exactly what they did here. They took the area to the left. The area to the left is 0.7422, and they did 1 minus 0.7422 and come up with this number here. And obviously, this is an easy way to check your mistakes. If you looked at this drawing that you made and you said 0.7, there's no way this is 70%. You can catch an easy error that way because you'd look at this and you'd be like, that shouldn't be more than 50%. It's not even half, right? So you should be able to catch errors like that. For number 7, it's kind of the same idea, except now you're using 2 points, so you're in between them. You calculate the z-score for one of them, calculate the z-score for the other, and then you can use the table to look up the areas related to those z-scores, both of them. Then you got to do some subtraction to find out the area in the middle where they don't overlap, because the table will show you area to the left. Well, the area to the left of 95, so the area to the left of right here, is all of this, including this tail that you don't want. So when you do your subtraction, you're taking the z-score from 70 and subtracting this piece, right? Because this is the only piece you don't want, right? So let me get rid of that instead of cluttering everything up. Okay, so same thing there. And then you can express it as either a decimal or a percentage. I think on the tests I ask for them as a decimal. Just round it to 4 decimal places and call it a day. Okay, here's this. Feel free to take a photo of that if you like. All right, and then these. These are more of the challenging questions, but it's the exact same stuff that we've just been talking about. All right, so let's move on to 2.6. Will Marty make it back to the future? This, move that out of the way. Okay, so like I said, anytime I'm going to address questions like this, I'm going to draw a little picture. So this is, here's the mean, here's the standard deviation, and honestly, don't draw the whole picture. I never draw the whole picture. Just draw the curve. It doesn't even have to look good. And then the mean is 80. Standard deviation is 7.7. I'm going to just write this down somewhere just for the sake of having it. But other than that, I'm not too worried about it. Value minus mean divided by standard deviation. What percent of runs will be less than 70 miles an hour? And that is the key information that I need. Less than 70 miles an hour. Obviously, 70 miles an hour is less than 80, so it's going to be somewhere to the left. And no, I don't really care where. So 70 is right there. I want values less than, so I'm going to shade the area to the left. And then I'm going to take 70 minus 80, divide it by the standard deviation. It's asking for what percent, so I'm about to produce a z-score here, which I'm just going to cheat and look at the answer key. Negative 1.3, negative 1.30. Now, if you take this and we go look it up in the z-score table, negative 1.3 right here, 0.0968. So what percent of runs? Instead of 0.09368, right? Or am I making that up? 0.0968. I don't know where I got the 3 from. Move the decimal point twice. This would be 9.68%. Easy peasy. All right, so I had to pause real quick so that I can go find the right website. But this 85th percentile question for number 2. Let me totally show you how to cheat this. So the 85th percentile. Now, if you want, you can look it up in the table, and that's totally fine. If you want to look at the 85th percentile, our mean and standard deviation will remain the same. We don't know his value. We know the mean, though, is 80. And we know the standard deviation is 7.7. What we're about to do with this 85th percentile thing is we're about to convert it to a z-score so that we can have only one unknown variable in this equation. So you can run over to the table, and if we want the 85th percentile, let's switch over to like hot pink. The 85th percentile is somewhere to the right, so it's in the positive z-score area. And 85th percentile. We're looking for 0.85 or as close as we can get to it. I think it's going to be this one right here, 0.8508. Just going to double check. If we go up one more, oh, they're actually missing the period right there. It's interesting. An error on the AP test. 0.8485. So this one is 15 away, and that one's way too high. Yeah, so we're going to go with that one. So this is 1.04. So 1.04. So the z-score is 1.04. And then equals, and then it's all this stuff. Now, you could sit here and solve for x. That's totally reasonable. I will show you how to do that by hand. It is not a big deal. Just to prove that it's not a big deal, we'll do this by hand. So on both sides, you will multiply by 7.7. So it'll cancel out from down here, and then on this side, it'll get multiplied. So this is, I need a calculator though. Calculator. I need 7.7 times 1.04. And now this is 8.008. 8.008 equals that minus 80. Then I can add 80 to both sides. So this will then become 88.008. So this is his speed. This is his raw value. This is x, right? So this equals x. So in this case, we're talking about Marty's speed in the DeLorean. What speed is needed to be at the 85th percentile? So if we were to just round that down, we would talk about 88 miles per hour, which if you watch the movie, you totally get that reference. If you didn't watch the movie, then too bad, so sad. Here's what else you can do, though. You can go on the internet and you can type in things like percentile to z-score calculator. And then you can tell it what percentile you need, and then it'll spit out a z-score for you. Here's what else you can do. You can do z-score to raw score calculator. And it's going to be one of these. Can we use this one? Nope, that's not it. Like I said before, this is literally all I would do if people would pay me to do their homework. Yeah, we don't know all those. Okay. It even just gives you the formula for it, so that's kind of nice. Just also, yeah, it sure is. Okay, so we know the z-score. We looked it up, 1.04. So 1.04. Our mean was 80 miles an hour. Our standard deviation was 7.7 miles an hour. And here's our raw score. So if you tell it the z-score, it'll spit out your raw score. So websites like this exist all over the place, and it makes doing the math really simple. The problem with what I do and what you would do is that I understand how all this works. So you need to understand how you can transform from a z-score to a percentile and back and forth before you can start doing stuff like this and cutting corners. So I can do this and cut corners and save time because I understand exactly what it is I'm doing when I'm like asking some random website to convert something for me. So if you can do that too, then God bless you. I'm hoping that eventually you will all reach that point where you have that amount of fluency with the procedure. Another website I'll show you is this one here, calculator.net. This is the one I pulled up on accident looking for the other one just now, but this website will give you, based on any raw score, so I don't know, 88 miles an hour, 80, and a standard deviation of 7.7. It will calculate your z-score for you. Not only that, so as you can see here, this is 1.038, so this would round up to 1.04. Not only that, it will also give you all of the areas associated with that z-score. So it'll tell you the area to the left, probability of x being less than, the probability of area to the right, so area to the right, and the probability of x being sandwiched in between the mean and the location that you're at. So in this case, the probability from the mean. It does some other calculations too. For example, down here, if you can read this and you recognize that this piece right here is calculating the probability of the area to the left of some place z, and you tell it a particular z, it can just be percentile, right? So you can find from a particular z if you type into this box, or if you want, say, the 87th percentile or whatever, then you just put 0.87 and you hit enter. And then it tells you what Z is at that location. So this is a super helpful website. It gives you the z-scores. It will give you the area to the left, the area to the right, the area in between, the area in between the positive and negative versions of that z-score, the area in the tails from that z-score positive outward and from negative outward. So it gives you everything. If you can learn how to use these websites effectively, then none of this is going to be problematic for you. So let's just blaze through these last couple. Also considering a CRX, a mean speed of 74, that goes there, and the 80th percentile is 88 miles an hour, so 88 miles an hour would be the 80th percentile. Find a standard deviation. So like I said, there is no place for percentile in this formula here. I got to take 80th and convert it into a z, which is what I'm going to use one of these calculators for. So I would grab this, type in 0.8, hit enter, and now this tells me that my z is 0.84. I'm going to just round it off, so 0.84. So my z is 0.84 equals value, but it's not giving me the value. Wait, what? Now you get to see Mr. Vallone struggle. Find its standard deviation. Mean speed of 74. 84 miles an hour. Yeah, that's the z-score. 0.84 is the z. So the mean is 74. So the 74 has to go here. I don't know the standard deviation. Oh. Duh. Since we're talking about this particular z, this 88 must go here. That way we only have one unknown. Okay. Mr. Vallone's COVID brain was not cooperating for a moment. So if you... Let's rewrite this nice and neat. This is a trick from Algebra 1. You can rearrange formulas. In this case, the formula for standard deviation, you actually can just switch the z-score and the standard deviation. You just swap places with them in the equation. And then you just calculate it like this. So let's grab a calculator. Why does it open up on that side? I want you over here. So now we take 88. I'm not really sure why that last video just cut off. That was weird. So you take this 88 minus the 74, divide it by 0.81. Your calculator will spit out this answer here. And then that's the end of that problem. So now we've got... Where'd it go? That's not it. Here we go. Am I crazy? I must be crazy. I am losing my mind actually today. That's... You'll love to see it. No, that's more of my writing. My God, I'm actually losing it. He's lost the plot. Let me just reopen another one. 2.6, answer key. Okay, here we go. So for your learning targets, it emphasizes here that you can solve for x, or you can solve for the mean, or you can solve for the standard deviation. All you need to do is rearrange the formula, or find yourself a handy-dandy calculator that'll do it for you. You've also got some of the more difficult questions down here. Obviously, you've got the challenges. All right, so what I'm going to do is I'm going to produce this for you on the same Canvas announcement that this video link is going to be posted in. So if you want some extra practice on z-score type stuff, there's this. I have a lot more practice where this comes from, but I won't grade any of it, right? So you can get as much or as little practice on this stuff as you want. Just let me know, and I'll print it out for you. So I'm going to put this into the same Canvas announcement. I'm going to go do that now. I hope you all have a great weekend. If you're watching this on Friday, if you're watching this on like Monday or Tuesday, then I hope you had a great weekend. So peace out.